everybody, today's practice problem comes from Principles of Economics by N. Gregory Mankiw. We're going to do, in this 6th edition, Chapter 3, Problem number 4. So the problem begins with the following. It says, suppose that there are 10 million workers in Canada and that each of these workers can produce either 2 cars or 30 bushels of wheat in a year. So we can start by just putting that information on our board or our paper or whatever it is we're working with. So we can say we have 10 million workers and they're producing one of 2 goods. We have either cars or bushels of wheat. So we could just say cars and bushels of wheat. Don't know why I just didn't put wheat, but I guess this makes the unit explicit, whereas the units of cars are pretty obvious. So then we can say, well, each one of those workers can either make 2 cars in 1 year. So this is all per year. We could either say that each worker could make either 2 cars or 30 bushels of wheat. So this would be for each worker. Or we could think about those 10 million workers in their entirety, right? So we could do that by just multiplying this each worker number by 10 million. So this whole country, I guess that country being Canada, according to the problem, which I think has way more than 10 million workers, but just let's go with it. We could say for all workers, well, 2 times 10 million is 20 million. And 30 times 10 million is 300 million. So the trade-off for the country overall is that if the country only made cars, it could make 20 million cars. Or if the country only made wheat, it could make 300 million bushels of wheat. It's important to remember here that this is an or situation, it's not an and. That it's not like a worker can produce 2 cars and 30 bushels of wheat. It's either one or the other, or some combination of the two if a worker or the entire country is allocating some of its time to one activity and some time to the other. Part A of the question asks, what is the opportunity cost of each of the 2 goods in Canada? So let's recall the opportunity cost of something is just what you have to give up in order to get it. So we can infer what the opportunity cost of each good is by just looking at the information that we have in our table. Now, if we look carefully here, we'll notice that what we've written down are rates of production, right? If I wanted to, I could say that this 2 was in units of cars per year, which is the rate at which a worker can make cars. And this number 30 is a rate of bushels of wheat per year, which is the rate at which one worker can make bushels of wheat, and similar for the countries overall. So we're already looking at rates rather than times, which is an important distinction to make because it's usually more helpful to think in terms of the rates of production. So we can think about here, we can actually investigate the opportunity costs either by looking at all workers together or by looking at each worker. We're going to get the same answer. And the math seems a little bit easier if we just look at the each worker situation. So if we think about it, if a worker could either spend a year making 2 cars or spend that same year making 30 bushels of wheat, then it must be the case that to make 2 cars, the worker has to give up 30 bushels of wheat. Or alternatively, the opportunity cost of 2 cars is 30 bushels of wheat. Well, if we just scale that down, it must be the case that the opportunity cost of 1 car, which is half of 2, is then half of 30. So you could say that the opportunity cost of a car is 15 bushels of wheat. If we do this in reverse and think instead about the opportunity cost of wheat, we could say, well, to make 30 bushels of wheat, we have to give up 2 cars. So the opportunity cost of 30 bushels of wheat is 2 cars. To get the opportunity cost of 1 bushel of wheat, we have to scale this down by a factor of 30. So then the opportunity cost of 1 bushel of wheat would be 2 divided by 30, or 1 over 15 cars. So, to summarize, we decided that the opportunity cost of a car was 15 bushels of wheat, and the opportunity cost of a bushel of wheat is 1/15 of a car. Now we did that by just applying some simple logic regarding trade-offs and then scaling that trade-off up or down as necessary. But we could also do this explicitly and think about the opportunity cost of a ratio of the rates of the different items. So we can say, for example, that the opportunity cost of the car is 15 bushels of wheat, which is equal to the rate at which a person can produce wheat divided by the rate at which the person can produce a car. So if we plug in the numbers, that's just 30 over 2, which in fact gives us 15. Similarly here, we could say that the opportunity cost of a bushel of wheat is just the rate at which a car can be made divided by the rate at which wheat can be made, which is just going to be 2 divided by 30, which is 1 over 15. The important thing to remember here, if you're going to explicitly use this ratio formula, which you don't have to, and you can rely on the logic instead so that you don't remember the formula backwards, but if you are going to use the formula, just remember that the thing that you're taking the opportunity cost of, that rate has to go in the denominator. Now the next part of the question asks, what do you notice about the relationship between the opportunity costs? Well, we can see here, just that's simply asking, what's the relationship between 15 and 1 over 15? And mathematically, those guys are reciprocals. And that's going to generally be true, that the opportunity cost of one of the goods in terms of the other is going to be the reciprocal of the opportunity cost of the other good. So far, this is all stuff that we've done before in a previous practice problem, right? So this in and of itself isn't particularly interesting, but it's a good refresher. But the reason I chose this problem is that part B of the question then starts explicitly asking about the production possibilities frontier. So part B of the question asks to draw the production possibilities frontier for Canada. And if you recall, the production possibilities frontier is just a map of all the different items that the country can produce if it's using all of its resources, all the different combinations of items. So in order to map that, we have to put each of our goods on one axis of our diagram. And you'll notice that the question didn't specify which good should be on the x-axis and which good should be on the y-axis. So you have to sort of decide one way or the other, and just make sure that your answer is consistent with the way that you've chosen to draw your picture. So here I decided, just sort of arbitrarily, that cars is on the y-axis and wheat is on the x-axis. So we can think about the production possibilities frontier by looking at what happens at the end points, namely where only one of the goods is getting produced, right? So we could say, now, because we're looking at the production possibilities frontier for all of Canada, now we're concerned with these all workers numbers here. So if Canada were to only make cars, it could make 20 million cars in a year. So if it chose to make no wheat, it could make 20 million cars. So the 0.0 bushels of wheat, 20 million cars, should be on our production possibilities frontier. So on the wheat axis, we'd be at 0, so it'd be all the way over here. And on the cars axis, we'd be at 20 million. So this point here is going to be one of the endpoints of our production possibilities frontier. The other one is going to be the point where we've decided to only make wheat. So say if we make 0 cars, we can make 300 million bushels of wheat. So the 0.0 cars, 300 million bushels of wheat has to also be on our production possibilities frontier. Well, 0 cars is all the way down here. And then 300 million bushels of wheat, let's say, is here. Obviously, this isn't to scale, but at least gives us an idea of what's going on. So this has to be the other point on our production possibilities frontier. And then the last thing we want to think about is what happens between these 2 points, because that's going to dictate what sort of shape we should draw. So we usually argue when there are trade-offs between resources that the production possibilities frontier has somewhat of a bowed-out shape. Because if we're going to start transitioning some people making cars or some resources making cars over to making wheat, if we're going to do so efficiently, we would start with those resources that are best at making wheat and worst at making cars, and so on and so forth. But here we're not given that type of information, so all we can really do is say, well, it seems like we face somewhat of a constant trade-off, or a constant opportunity cost, in that it's not changing depending on how many of each of the goods we're producing. So if we're facing a constant opportunity cost in this way, and all the information you're given is in a table that looks like this, we know that the best we can do is to draw our production possibilities frontier as a straight line like this. One thing that's interesting to note about the production possibilities frontier is its slope. So if we were to look at the slope of this line, we just know mathematically, slope equals rise over run. So the slope here would be negative 20 million rather, divided by 300 million. So our slope is going to be negative 1 over 15. And you say, hey, that number looks kind of familiar. Well, check this out. The slope, or at least the absolute value of the slope, is equal to this opportunity cost here. So we can think about what's going on, that the slope of our production possibilities frontier is actually the opportunity cost of, well, in this case, wheat, in more general sense, the thing that's on the x-axis. So it's just helpful to think about. And then the problem continues to say, if Canada chooses to consume 10 million cars, how much wheat can it consume without trade? And then it asks you to label the point on the production possibilities frontier. So I'm actually going to start by labeling the point, and then we'll do some math later. So if Canada chooses to consume 10 million cars, then 10 million cars is going to be here on our cars axis, right? So we can then look at the point on the production possibilities frontier that corresponds to 10 million cars, and we're going to get something like this. So what we want to figure out then, mathematically speaking, is where quantitatively this hits on the wheat axis. There are 2 ways that we could figure this out, actually. So one way is to notice that we can just scale up this trade-off. So if we said that the opportunity cost of a bushel of wheat was 1/15 of a car, and the opportunity cost of a car was 15 bushels of wheat, then it must be the case that for every car we give up, we get 15 bushels of wheat. So if we look over here, when we go from 20 million cars to 10 million cars, we give up 10 million cars. Which should mean that we get 15 times 10 million bushels of wheat, right? Because for each car we get 15, so in total if we give up 10 million, we get 15 times 10 million. And you'll notice that this is just 150 million bushels of wheat. So that tells us here, just looking at the opportunity costs and scaling that up, this tells us that if we go from 20 million to 10 million cars, we go from 0 bushels of wheat to 150 million bushels of wheat. That's not the only thing we could do. We could also look at this and say, well, wait a minute. If I go from 20 million to 10 million cars, then it must be the case that rather than spending all of my time making cars, I'm only spending half of my time making cars. If I'm only spending half of my time making cars, then I can spend the other half of my time making wheat. And we notice if I spend all of my time making wheat, I get 300 million bushels. So it must be the case that if I spend half of my time making wheat, I get 150 million bushels. So there are a number of things that you could do here. As long as you're doing something that makes logical sense, you're going to get to the same answer. Now, in the last part of the problem, we get a trade to consider. So here, it says, now suppose that the United States offers to buy 10 million cars from Canada in exchange for 20 bushels of wheat per car. So what we're really saying is Canada has the opportunity to sell 10 million cars for, we said 20 bushels of wheat per car. So this should be sell 10 million cars for 20 times 10 million bushels of wheat, right? So it should be 10 million cars for 20 million bushels of wheat. So we're trying to look at this trade and see whether this is a reasonable trade and understand if we made this trade, how much Canada would now be able to consume, whereas before Canada could only consume what it produced itself. So we could think about, in the absence of trade, this production possibilities frontier is almost by definition also a consumption possibilities frontier. But now we're breaking that and saying, well, now you get to consume stuff that's different from what you specifically produce. So it says if Canada continues to consume 10 million cars, so they're consuming 10 million, and then they can make a total of 20 million. So let's consider a situation where they're consuming 10 million and they're selling the other 10 million, because that's the only way that they can both make this deal and continue to consume 10 million cars. So we're saying, well, now they're producing 20 million cars and no wheat on their own. They're selling 10 million of those cars and they're getting 200 million bushels of wheat. So this is how much wheat does the deal allow Canada to consume? Well, it's not consuming any wheat that it produced, because we can see that it's not producing any wheat. But it is consuming the wheat that it gets in this trade. So we can say if we do this, then Canada, if it chooses to only make cars, Canada can produce 20 million cars and 0 bushels of wheat. But then it can consume, after it sells the 10 million cars, it can consume the other 10 million cars and the 200 million bushels of wheat that it gets in the trade. So, and 200 million bushels of wheat, right? So we'll notice here, if we wanted to label this on our production possibilities frontier, this deal would net us consumption that would be out here somewhere, right? The 200 million would be about here. So this deal would allow Canada to have consumption out at this point, which by itself, in the absence of trade, was outside of the production possibilities frontier. So this is more consumption than Canada could have without the trade. It's like, we're seeing another example of how trade can make parties better off, in that by specializing and selling some of what it's doing, it can actually get to a point where it has more of both goods than can be found if it's only consuming what it's producing. So it says, should Canada accept this deal? Well, there are a number of ways of seeing this. The easiest is to say, well, yeah, it should accept this deal because accepting the deal allows it to expand its consumption possibilities beyond what it had as its production possibilities. We could also think about this in terms of opportunity cost. that you'll notice over here, when we were talking about opportunity costs, we said it costs Canada 15 bushels of wheat to make a car. We're being offered a deal where Canada is being paid 20 bushels of wheat for each car. So, we're getting paid more than it cost us to produce cars. It's not surprising then that would make Canada better off, because it makes Canada better off in exactly the same way as any producer is better off when it can sell an item for more than it costs to produce that item.